module 2 and the last class of module 2. Okay. So what exactly we mean by interconnected systems? What exactly we mean by interconnected systems? Earlier we considered that only one system, say 25, 50 megawatt, that's one system. Only one system we considered. But here we will consider two systems, system A and system B. Just like you read about two area systems in your power system analysis, you read about two area systems. So here we consider two systems. Earlier case we used to compute the capacity outage table of system A, okay, and find out the various risk indices. Which are risk indices are LOLE, LOE. So this is the generation model. Then you have the load model. We combine them to get the risk indices known as LOLE and LOE. Okay. Similarly, the system B will have all its risk indices, but when some capacity outage is there in system A, if we can supply some power binding some tie lines, then we can improve the reliability of system. So that's why this system is known as interconnected system. Okay, as it is happening throughout the whole grid, but here we are considering only two. As with two area system for ADC, we consider only two interconnected systems. Okay. So whatever I have told you is written here. The adequacy of the generating capacity in a power system is normally improved by interconnecting the system to another power system so that it can provide power whenever required. Each system can then operate at a given risk level with a lower reserve, because if system A is interconnected with system B, then system B can act as a reserve. So instead of its own reserve, system A can take power from the system B. This is due to diversity of probabilistic occurrence of load and capacity outage. In two systems, the load will be different. You might have read in your undergraduate level diversity factor. It simply says that it is very undesirable, it is extremely undesirable that all the consumers will have their peak loads at the same time. All the consumers have different usage behavior and they will have the peak loads at different times. And that's why you do not need too much of transformer capacity. Similar with this. Okay. So here there are two basic approaches for computing the risk indices. Okay. One is probability array method and equivalent assisting unit method. We will discuss only one, probability array method. Okay. So in the first method, so you mentioned this. So a 2-mark question can be asked in your exam. What are the approaches to computing risk indices for interconnected systems? So two approaches are, write down, mention there. Two approaches are probabilistic array method and equivalent assisting unit method. So what is the philosophy behind probability array method? The philosophy is that a capacity model is developed for each system and an array of simultaneous capacity outages, okay, and their probabilities are obtained from the individual models. So this is known as probability array method. Okay. So just mention these two names only, and in the exam if it is asked what is probability array method, then write this answer. Okay. What is, as the name says, for the second method, the assisting system is an equivalent assisting unit. So we consider the second system to be a completely different unit, which is part of system A. Okay, that's why it is equivalent assisting unit method. Okay. Fine. Two approaches, but we will focus on only one. Okay. So now, what is probability array method? So again, I am repeating the basic of power system generation reliability is that you make one generation model, right, which is basically the capacity output, COT, right, capacity output. Then you have load model. What can be the load model? Daily, no. Load model is daily peak load variation or the load duration curve. That is load model. Now when you combine them, you get the risk model. You get the risk model, which is the reliability. So when you say power system reliability, we mean this model. And this model is essentially only two, which are widely used. Yeah, loss of load indices and loss of energy indices. Okay. So the loss of load situation arises when the available assistance through the interconnection cannot meet the capacity deficiency. The calculated LOA index therefore depends on the simultaneous occurrence of the capacity outages. So for an interconnected system, if simultaneously capacity outages occur, then only the load loss will be there. Okay. So generation facilities in each system can be represented by a 2D probability array covering all the possible combinations of the capacity outage of two systems. The representation can then be modified by including the load levels in each system and tie-line constants. Okay. See here this is also very important. Suppose system B has 20 megawatts spare capacity and system A needs that, but the transmission line capacity is only 10 megawatt. Right. So it can provide maximum 10 megawatt, not more than that. Right. So what are the various steps involved in probability array method? The first step is develop the capacity model of each system, just like our normal method COT. COT of system A, COT of system B. Okay. But the second step, then you get the probability array of various simultaneous outage probabilities. Okay. And finally compute the loss of load situation. Okay. Right. So these are the three steps using probability array. So this diagrammatically depicts what is probability array method. So nothing of significance, just diagrammatically. For example, when both are up, no requirement of any supply. Okay. And if there is no interconnection, then no supply can be made. Whereas when there is an interconnection, the capacity of the system may increases because there is an interconnection and power can be supplied. Just depicts that, nothing much. Okay. Now our objective is this problem. Okay. So I told you there are two systems. You just mentioned there in your note. Example. So what you mentioned, that first system has a capacity of, system 1 has capacity of 75 megawatt, system A, or I would better say, and system B has a capacity of 60 megawatt. Just mention that system A has a capacity of 75 megawatt, system B has a capacity of 60 megawatt. System A has a load of 50 megawatt, and system B has a load of, when I say load, it is peak load. It's the peak load of 40 megawatt. Okay, write down. Okay. System A has 75, 60, peak load is 50 and 40. System AB. So two systems are connected by a finite tie-line capacity of 10 megawatt. So the third important point is the tie-line capacity is 10 megawatt. Okay. So maximum assistance from B to A or A to B can be 10 because the tie-line capacity is 10. The operating agreement between the two systems is that each system will provide assistance only up to the point at which it begins to share the neighboring system difficulty. Okay, so it can only provide whatever it can provide without compromising its own load. Okay, so we are going to use probability array method. Okay, so we'll go to the Excel sheet how it is calculated. So in the Excel sheet, in the first case, I have written the steps, first sheet. So we have discussed it. First is obtain the capacity outage table of individual systems, system A and B separately. Then see the load, what is the peak load. Third case, find out the risk index in each case. Okay, and finally obtain the simultaneous outage. This is the most difficult part of this. Okay, so first part we will go to the individual case. Okay. So we have here system A has 5 10 megawatt unit, 1 25 megawatt unit. Total number of units is 6. System A has 6 units, right? 5 plus 1, right over. Total units in system A 6. Total units in system B 5. Okay. Total capacity is 10 into 5 plus 25 75. 10 into 4 plus 20 is 60. Okay. And FOR we have assumed to be 0.02 for everyone. FOR means forced outage rate. That means availability probability is 0.9. 0.02 is the outage rate. Okay. And load is 50/40. Now system 1, system A. Okay. System A. Right? How many units we have?
5 units of 10 megawatt and 1 unit of 25 megawatt.
20 megawatt. 5 units of 10 megawatt and 1 unit of 25 megawatt. Total 75. But we can have different combinations. For example, you can have all the capacity outages. How? That is mentioned here. So if you see here, so for system A, you can think of the 10 megawatt units to be out and slash or 25 megawatt units to be out. Okay? Capacity outage 0. That means capacity outage 0 means no outage. None of the 10 megawatt units is out. None of the 25 megawatt units is out. What is the probability? As you know, total unit is 510 megawatt. 5 C 0, FOR 0 into 1 minus FOR to the power 5 for the 10 megawatt case. And 1 C 0, FOR 0, 1 minus FOR to the power 1. This is for 125 megawatt. This is for 510 megawatts. Okay. So this condition arises when this happens and this happens. Right? So compute these two, you compute these two values. Compute. Okay. So this is 0.9039, this is 0.98. As you said, if you multiply, it should come as 0.8858 something. So we'll check, we'll cross check it. Yes. So this is 0.88584238. So first one is 9, as you have rightly calculated, correctly calculated, 90392 into 0.98. So this is for 0 megawatt capacity. Now we will see when 10 megawatt capacity outage occurs. Okay? Try to understand this. 10 megawatt capacity outage. Now 10 megawatt capacity outage occur only when one out of those 5 10 megawatt units is out. Right? One out of the 10 megawatt unit is out. Whereas 25 megawatt unit is as such. Okay? So therefore it will be 5C1 FOR to the power 1 minus FOR to the power 5. Okay? And 1C0 this. So this is actually 0.98 again. Okay? Can you tell me what is this? It will be exactly same as this, but you will multiply 5. Right? How much? 0.4 point.
It is 0.9.
Say probability.
So
It will be 5 into 0.98. 0.02 because FOR to the power 1 is there, na? So into 0.02 into 0.98. It will be 4, right?
yes sir.
4. This should be 4. 0.98 to the power 4. How much is coming?
0.092.
0.092.
092.
This one, the whole thing 5 into this is equal to 0.092.
Yes sir.
Okay. So this is 0.092. This is 0.98. So if you multiply both,
0.0903. 0.0903.
0.039. Okay. Check again. Yes. 0.09039. Okay. Right. So this is for 10 megawatt. For 20 megawatt, it's very simple again. The same thing. Any 2 out of 10 megawatt and 0 units out of 25 megawatt. This is all is available. So you get this type C to FOR to 1 minus FOR 0 into this one.
Sir, 1 minus FOR to the power 3 होगा.
Yes. This should be 1 minus f power e power 3. So this should be 3. Okay. So this should be 3. Should be 3. So, but in the table it is multiplied correctly. Okay. And this one. So that should be straightforward, no problem. Now coming to 25 megawatt. It should be no 10 megawatt, but 125 megawatt. So it's very simple. It is 0.988. This should be 0.988.
No, so this will be
0.98 and this should be
this
this
is
should be
0.02.
0.02. Yes.
27 and 1 1
This is 0.02. This is 0.98. This is 0.98. This is 0.02. Because 10 megawatt is available. Okay. No outage for the 10 megawatt. Oh, we'll see. Okay, we'll see about that.
So sir,
So-
0.9039.
0.9039.
Yes.
Okay. Because it is to the power 5 is there. No problem. So again we will see. So for 0, 10, 20, 25. So we have got all these things. Same thing. Okay. 30 also same. You have straightforward 3 units out of 10 megawatt and 0 unit out of 25 megawatt. Same way you will calculate. Okay. But when it comes to 35, 1 unit out of 10, 1 unit out of 25. Okay. So accordingly you will write here. Now what about 40? 4 10 megawatt units. Okay. 4 10 megawatt units. 45, 125 to 10. 50, 5 10 megawatts. Okay. And so on. Okay. So like this we will compute for the system A. Okay. The capacity of this table for the system A. Now we will come to system B. System B has 4 10 megawatt, 120 megawatt. Okay. System B has so for 0 megawatt outage is simple, straightforward. None out of the 4 10 megawatt units, none out of the 25 megawatt multiply. But when it comes to total of 20 megawatt, 10 also for straightforward, only 1 out of 10 megawatt. Now this you compute for 20 megawatt. 20 megawatt, what is the situation? So you have this and this, or this and this. That means you will find out the probability here, multiply, then probability here, multiply, add both probabilities. Because 20 megawatt outage is there when either 2 out of 10 megawatt and none out of 20 megawatt, or none out of 10 megawatt, 1 out of 20 megawatt is out of service. Compute.
So for 20 megawatt.
Okay. So therefore, the final probability will be this into this, and we add up both. Okay. So when you multiply these two, what is the probability?
2.25.
2.2588. 0.000. 58. Okay. Second,
0.0184.
0.84.
473.
47. Now when you add it up, how much is coming?
0.020705.
0.02.
07.
07.
05.
0.
5.
Okay. So note this number. We will check whether it is correct or not. Okay. Yes. For 20, right? Right? So total is 0.02079936. Did we find it correctly? Yes. So you multiply this two, then multiply this two. Okay. Then add it. Right? Now this for system B, you see there are so many combinations. For example, for 20 there are two cases. For 30 we have either this or this. For 40 we have either this or this. So accordingly you have to find out the capacity outage table probabilities. So in the end we have got individual capacity outage of system A and system B. Okay. So in the end we have individual capacity outage tables of system A and system B. Right? So this is the intermediate state. Now you have got the capacity outage tables. The next step is, what is the next step? To find out the simultaneous. Okay, the next step is finding the simultaneous outages. So far what we have done? So far we have seen there is a system A of 75 megawatt capacity. There is a system B of 60 megawatt capacity, which are connected by a tie line of 10 megawatt capacity. Okay, and in the first step we get capacity outage table of system A and also capacity outage table of system B. Okay, so first form the capacity outage table of each system. Right. Second, neglect if it is 0.00 up to 10 to minus 8. If it is beyond that, it's 0. It is considered to be 0. Okay. The peak load in system A is assumed to be 50, which is given in the question. Okay. So what is the capacity of system A? 75 megawatt. The capacity of system A is 75 megawatt. Peak load is 50 megawatt. So how much outage is allowed? Maximum. Capacity 75, load 50. So how much outage is maximum allowed? What is the outage after which there will be the demand will not be met, load will not be met. Load is 50 megawatt. Capacity is 75 megawatt. 25 megawatt. So if the capacity outage is 25 megawatt or more, then this load cannot be met and we have a loss of load situation. Okay. That is what is intended. Therefore, if we have to meet the demand with the capacity outage is less than 25. The cumulative probability of capacity outage of 30 megawatt becomes the LOLE index in system A. Okay, that will find out from the Excel sheet. So you just mention LOLE. Just mention that LOLE equal to I will give you. We'll see from the Excel sheet. Okay. Similarly, system B. What is the load of system B? System B. What is the load? What is the question? 40 megawatt. In the system B, the load is 40 megawatt. Capacity is 60 megawatt. So how much maximum outage you can say? 20 or this 20 megawatt is basically a reserve in system B. So when it has no outage, it can provide this 20 megawatt to system A. But then it is limited by the 10 megawatt capacity. Right? Okay. So system B has a reserve of 20 megawatt and it will encounter a loss of load situation for any capacity outage greater than 20 megawatt. Okay. Okay. From the Excel sheet, mention these numbers. You can find out from the Excel sheet. LOLE A and LOLE B. Mention these numbers. Okay. So now we have the risk indices of system A and system B separately. Mention in your notebook. You mention these two numbers.